Three Idiots, a must-watch Bollywood film. It's filled with loads of laughter, amazing songs, creative storyline, an important message, and examples of innovative systems engineered by a Jugad genius. Consider this scene from the movie, for example. So let's break down how this system would have been built. You can see that the drone is hovering in a very stable manner. This level of stability can only be achieved by the use of an IMU. IMU is a group of sensors that tells the onboard controller which side the drone is tilting. Based on this information, the onboard controller makes sure that the drone is in stable position. Apart from the IMU, we have a camera sensor on the drone that is transmitting the output of the camera to the display on ground. The onboard controller is also receiving instructions from the remote controller, and based on those instructions it is driving the propellers, and it is also sending the respective commands to the camera actuator. Well, now the question is, how are you going to build this Rancho operated system? So you would require the hardware components, and then you need to connect all of them in some fashion to make the system work. So in order to understand the interconnection between the subsystems, we will have a look at the block diagram that we've developed. So now if you carefully look at this block diagram, you see that all these hardware components that we have listed work together to make the system work if and only if these lines of communication are established. Well, this is a very basic and a simple system, but if you want to build more and more complex systems, communication between the subsystems become more and more important. So, how does an effective scalable communication strategy look like?
For this, let's have a look at how content is shared on YouTube. So on YouTube, we have three parties: content creators, subscribers, and the mysterious YouTube algorithm. For now, let's just tuck away the third party for a while. The content creators create videos and publish them on their channel. You, as a subscriber, can subscribe to their channel so that whenever a new video is posted, you get notified. The YouTube itself acts as a platform that connects the publishers of the content with the subscribers. What if there was a platform like YouTube on which the data is published and the controllers subscribe to these channels to get the data, process it, and publish the propeller speed on their own channel for the target audience, that is the propellers. This model allows n number of sensors, actuators, and controllers to be easily integrated with the system. Well, we have a pretty scalable model here, don't we? We have a nice scalable communication strategy to control the Rancho operated system. The world knows the Rancho operated system as ROS. ROS stands for Robot Operating System. Even if it says so, ROS is not actually a real operating system, rather it goes on top of Linux Ubuntu. ROS is a framework on top of the OS that allows it to abstract the hardware from the software. This means you can think in terms of software for all the hardware of the robot. ROS is a collection of tools, libraries, and conventions that aim to simplify the task of creating complex and robust robot behavior across a wide variety of robotic platforms. There are a ton of libraries for almost any sensor or hardware that you would like to incorporate into your robot. So you could focus more on implementing the control flow rather than focusing on getting your sensor outputs into an understandable form.
That was a very brief overview of what ROS is. Let's take a look at how the AUV society has been using ROS. We have developed the control algorithm of our vehicle using ROS. We execute the same code for testing our vehicle in both simulation and real world. Using an allied tool called Gazebo, we have developed a complete testbed for SAUVC. Apart from underwater simulation and testing, motion of aerial vehicles can also be visualized. How can you start your journey in this field? Check out the description of the video.